Example 2, a recent survey found that 59% of college students attend more than one institution during their college career. Suppose a sample of 6 students is chosen. Assuming that each student's college attendance pattern is independent of the others, find the probability of each of the following. A, exactly 3 of 6 students attend more than one institution. Okay, so this is a binomial probability problem, and we can use that formula again. Notice they give you P, that's the probability of a success, and they're giving you the 2 numbers right here, 3 of 6. So 3 is the X number and 6 is the N number. So there's a very straightforward application of our formula. 6 choose 3. It means 3 successes. So 0.59 is going to happen 3 times. And then 1 minus 0.59, you've got the probability of failure. Notice this has to add up to 100%. That's going to be 0.41. And if 3 of the 6 students do it, then that means 3 of the students do not do it. Notice that these 2 exponents have to add up to 6. They have to add up to that big number in the front. Just a calculator problem at this point. About 0.2831. So the probability of exactly 3 students attending more than one institution, about 28% or so. How about none or 0 of the 6 students? Okay, so it's the same thing. We've got N is 6. This time we're selecting 0 of those. And so if there are 0 selected, there'd be 0 of the 59%. And that must mean that there are 6 of the 41%. So again, if you understand how this works, a couple of these things cancel out. Once you get familiar with this, you'll know that's 1 and that's 1. So really all we're doing is 0.41 to the 6th. Let's just make sure 6 choose 0 is 1. Okay. So really all I have to do is 0.41 to the 6th. If you didn't know that, you just type in the whole thing. It's fine. Here, if you did 4 decimals, it's 0048. I'm going to go ahead and do 00475. Just give me enough decimals to be descriptive. Find the probability of getting exactly 7 heads in 8 tosses of a fair coin. Okay, so here's a different experiment. 7 in 8, so that's your X number and your N number. They don't give you the probability, the P number, but we're talking about tossing a fair coin. So if we're tossing a fair coin, we know that probability is 0.5. Probability of flipping heads up is 0.5. So it's the same exact formula. We've got 8 total experiments, and we're looking for 7 successes out of that. So 0.5 to the 7th power. Now, if 0.5 is the successful probability, then that means 0.5 will be the failure probability, and that's going to fail 1 time. Again, keep in mind, the 2 exponents have to add up to the big number, 8. 7 and 1 make 8. .03125. Number 4, the FTC monitors pricing accuracy to ensure that consumers are charged the correct price at the checkout. According to the FTC, 29% of stores that use checkout scanners do not accurately charge customers. So there's your P number right there. A, if you shop at 3 stores that use checkout scanners, what is the probability you'll be incorrectly charged in at least 1 store? So when they say language like at least 1, we know that means 1 or 2 or 3, since we're going to 3 stores. 1 or 2 or 3. So I see a couple of plus signs. So we're going to have to go this plus this plus this. And I'll see that formula 3 times. N is 3. And then these numbers are the x numbers. So we will have 3, choose 1, success. And success rate is 0.29. That means the failure rate, 1 minus 0.29, that would be 71, right? 71%. And there are 2 of them. Plus, now we'll do 2 successes. 3, choose 2. There'd be 2 successes and 1 failure. Or now we're going to have 3. So 3, choose 3. 3 successes and 0 failures. Okay. So I think you're probably getting the hang of the formula. When you plug this blue one in, you're going to get about 0.4386. And then you plug the red one in, you get about 0.1791. And then we're going to have the green one, and that's 0.0244. Add them all together, and you get about 0.6421. Now notice I rounded off. You want to be careful with the rounding. Sometimes if you want to end up rounding to 4 decimals, you should maybe round off to 5 here, just to make sure. Sometimes when you round off to 4 decimals and then keep it at 4 decimals, there's some sort of round off error, like maybe that was supposed to be a 2. Just be careful with your rounding. I think a good rule of thumb is if they want 4, then keep 5 until the end. One thing that's interesting, though, there's a different way of doing this same problem. If they're talking about at least 1, and we knew it was 1 or 2 or 3, there's another way of doing it and saying that we don't want 0. Okay, another way of doing this same problem would say the probability of not 0. Because we know from previous lessons that we can do the probability of not 0 is one minus the probability of 0. So think about that. 1 minus, and let's look at 0 successes. So it'd be 3, choose 0, and it was 0.29, right, to the 0 power times 0.71 to the 3rd power. So 3, choose 0 is 1, and this is going to be 1. So basically we've got 1 minus 0.71 to the 3rd power. Should be the same thing, 0.6421, 0.6421. Same thing. So keep in mind, you're going to see problems that are going to have different ways of doing it, okay? If you can see a faster way of doing it, then do it that way. Part B says, if you shop at 3 stores that use checkout scanners, what's the probability you will be incorrectly charged in at most 1 store? So make sure you're good at the English language. At most 1 means 0 or 1. Okay, 0 or 1. So I'm kind of out of room here, but if we know 0 or 1, we would have 3C0 times 0.29 to the 0 times 0.71 to the 3rd plus 3C1 times 0.29 to the 1st times 0.71 to the 2nd. Okay, so we add that up. Okay, type each of those things in. You're going to have 0.3579 plus 0.4386, and that's about 0.7965.